Dear student, in the two videos we learn the topic physical world. In a physical world, I already explained there are 5 important major objectives. Out of these 5 important major objectives, we already learn what is physics. You got a clear idea. Along with that, we learn scope and exactment of physics, application part of physics we learn, and third important objective, physics, technology and society. And what we learn in physics, how we can use that concept in technology, and what are the use of that technology in the society. These 3 important objective part we already learn. And remaining 2 objective part is fundamental forces in nature and nature of physical law. These 2 objective part we are going to learn in this video. Dear student, we start with the 4th important objective part of the physical world topic is fundamental forces in nature. We start with that concept. Here, fundamental forces in nature. There are 4 important fundamental forces in nature. Remember this concept clearly in your mind. Here, these 4 important fundamental forces in nature, usually they will ask for exam. It may be for 1 mark or it may be for 2 marks. Just you have to mention the 4 forces in exam. We will discuss all the 4 forces called fundamental forces in nature one by one. In that, first important force is called gravitational force. Dear student, you already heard about gravitational force in lower class itself. Gravitational force is the force of attraction. Between 2 masses. It may be a smaller mass or it may be a bigger mass. We can see the gravitational force of attraction. Dear student, you already know the gravitational force of attraction between 2 masses. If we take mass m1 and the one is mass m2, these 2 masses are separated by some distance. I consider 2 masses m1 and m2, both we call it as point masses. We'll discuss in detail about point masses in a coming chapter like gravitation chapter, and up to that remember we consider 2 point masses separated by some distance. These 2 point masses we can take an example like gravitational force of attraction between earth and moon, or you can see the force of attraction between earth and sun. Here I consider 2 point mass m1 and m2. We may call m1 is the earth, m2 is the moon, or m1 is the earth or m2 is the sun, or you can call m1 is this top or m2 is this pen. Any 2 point masses separated by some distance that we call it as r. In between these 2 point masses we can think of gravitational force of attraction. That gravitational force of attraction formula we got by using Newton's law, that we call it as Newton's universal gravitational law or universal law of gravitation. And this law, or we say that Newton universal law of gravitation is universal, is applicable each and everywhere, and here range itself we can say that infinite. Now it is a first important thing, gravitational law. It is a force of attraction between 2 masses. And second important fundamental forces in nature we call it as electromagnetic force. The name itself indicates a combination of 2 systems, electric and magnetic, that we call it as electric effect and magnetic effect. In other words, we can call electric field and magnetic field together. It provide a force we call it as electromagnetic force. That electromagnetic force is the force between charged particle. Keep this condition in your mind. Electromagnetic force is the force between charged particle. There are 2 systems we can think. I already said electric and magnetic. Together we call it as electromagnetic force. And when we get the electric effect, when we get the magnetic effect, we discussed now, charges are at rest. If I consider any charge is in the state of rest, usually we denote charge by letter Q. And I consider any one sphere, it got a charge is equal to Q. Around this sphere, we can see the region. That region we call it as electric field, denoted by letter E, where E vector, here arrow mark represent the symbol of vector. E vector represent the electric field created around a charged body. It is denoted by letter E. And if the same charge is in the state of motion, we say the charges are at motion. We can see the second effect, we call it as magnetic effect. If same charge is in the state of motion with a particular velocity, I denote that velocity by letter V. Automatically around this charger particle, we can see the electric field as well as one more field also that we call it as magnetic field, B vector. Keep these 2 points in your mind. If charges are at rest, we can see only the electric effect. If charges are at motion, we can see the only magnetic effect. And here the important thing is, at motion we can see electric field as well as magnetic field. Usually to get the magnetic effect, we have to assume the condition that charges are at motion. If charges in the state of rest, we can see the electric field, but there is no magnetic field. If charges are at motion, we can see the magnetic field. Along with that, we can see the small effect of electric field also. That's why charges are at motion, we can see the both electric field and magnetic field. It is a second important fundamental force that we call it as electromagnetic force. And third important thing is called strong nuclear force. You already heard about nuclear force. Here I use the word strong nuclear force. The word strong nuclear force is mainly gives idea related to nucleus. That's why strong nuclear force is the force which binds or combine protons and neutrons. You already heard in a nucleus we can see the two particles, the particle called proton and neutron. In between proton and neutron there will be a strong force of attraction. That strong force of attraction we call it a strong nuclear force, is the strongest force in the nature. And the fourth important thing is weak nuclear force. This weak nuclear force is appeared only in a certain process. That's why this appears only in a certain nuclear process. Keep this point clearly in your mind. This appears only in a certain nuclear process such as beta decay. Keep one point clearly in your mind. You already heard about Madame Curie. She is a scientist. She discovered radioactivity. That radioactivity mainly discovered by scientist Becquerel and clearly explained by Madame Curie or Curie and team. And again in a radioactivity process we can think about three important rays or radiations. Usually that radiations are called alpha rays, beta rays and gamma rays. And this one is due to disintegration process, or we say the decay process. If you think about any radioactive sample or any one nuclei or nucleus is kept it for a long time, it undergo decay process by emitting the three particles. The three particles are called, it may be an alpha particle or it may be a beta particle or it may be a gamma particle. And especially weak nuclear force arises due to process called beta decay. Here especially beta decay is nothing but emission of electron, or it may be emission of positron. Keep 2 points in your mind. Beta decay involves two important processes. One is called beta plus and the one is called beta minus. Due to emission of positron we call it as beta plus. Due to emission of electron we call it as beta minus. That's why this weak nuclear force arises during a process or nuclear process such as beta decay. We are going to discuss in detail about all those things in the first year as well as second year. Up to that, remember these four important fundamental forces or basic forces in nature. One is called gravitational force, and this gravitational force is the weakest force in the nature. It is a very less value of force, or its range is large, but the strength is less. That's why it's called the weakest force in the nature. Second important thing is called electromagnetic force. Is a combination of electric and magnetic field together. Charged particle will experience a force is called as electromagnetic force. And third important thing is called strong nuclear force. That force will bind protons and neutron inside a nucleus. Its range is very small. And fourth important thing is weak nuclear force. This arises under certain nuclear process such as I already explained about beta decay. During beta decay we can think of weak nuclear force. Continuation of this, we'll see the particular range as well as their strength of 4 basic forces or fundamental forces in nature. I consider here columns. In this column I consider first column name of the force. In a second one I taken its relative strength, and third one I consider range, and fourth one operates among. And again we consider all the 4 fundamental forces one by one. First one is called gravitational force. First one is the gravitational force. Relative strength of the gravitational force, when you're going to compare with the strong nuclear force, I taken relative strength is 1 here, and when you're going to compare with these two, the relative strength is 10 power minus 39. That indicates that value is very small. 10 power minus 39 is very small. Due to that reason I said gravitational force is the weakest force in the nature. And again I said range. Range is infinite. Why it is infinite range? We consider gravitational force in between celestial body or any 2 planets or any 2 objects. That's why the range is infinite. You can see the gravitational force between Earth and Moon. Distance is very large. We can see the gravitation force between sun and other stars. The distance is very large, infinite range. Along with that, it operates among all objects in the universe. Starting from the small object to bigger object, we can see the gravitational force. That's why operating system, we say that operates among all object in the universe. Universe, whatever object is present, in between that object or smaller masses, we can see the gravitational force. And the second important thing is weak nuclear force. Weak nuclear force having relative strength is 10 power minus 13 when you're going to compare with strong nuclear force, and its range is very short, of the order 10 raised to minus 16 meter. See this range, 10 raised to minus 16 meter is the range. Very short. And apart from the, again we are going to see the 2 particle range is 10 raised to minus 10. We can't see the weak nuclear force. 10 raised to minus 12 gap. We can't see the weak nuclear force. We can see the weak nuclear force for very short gap between the particle is of the range 10 raised to minus 16 meter. That's why it is called subnuclear size. Under subnuclear size, not only a nuclear size, is under subnuclear size, inside a nucleus. Under subnuclear size, we can see the weak nuclear force, and it's operating among some elementary particles such as electron and neutrino. Neutrino is also one of the elementary particle. Elementary particles are nothing but building blocks, particles of this entire nature or universe. That elementary particle, it may be an electron, it may be a proton, it may be a neutron, or it may be a neutrino. Neutrino is also one of the elementary particle. We discuss in detail about neutrino in a second year radioactivity topic. Up to that, remember, neutrino is the one particle comes during nuclear process like beta decay. Beta decay process alli baruva particle anna we usually call neutrino. And the third important thing is electromagnetic force. Range of electromagnetic force is, or relative strength of electromagnetic force is 10 raised to minus 2. Range is infinite. Again we can see the infinite range for electromagnetic force. This force arises if charged particle presents in a system like electric field and magnetic field. That range is infinite, and its strength, relative strength, is 10 raised to minus 2 when you're going to compare with strong nuclear force, and operates among charged particle. We already learned. And the last one is strong nuclear force, and its relative strength is 1 when you're going to compare with the remaining 3 fundamental forces, and its range is very very short range or short range of the order 10 raised to minus 15 meter. It is a short range of the order 10 raised to minus 15 meter. 10 raised to minus 15 meter is the size of the nucleus. Inside a nucleus or in a nuclear size, we can see the strong nuclear force. That's why strong nuclear force operates among nucleons or heavier elementary particle. Nucleons are nothing but two types of nucleons are there. One is proton and the one is neutron. Whatever particle present inside the nucleus are called nucleons. There are two particles present inside the nucleus. One is proton and the one is neutron. That's why proton and neutron are called a nucleon. That's why it operates for a nucleon. It operates for a heavier elementary particle. By seeing this table, we come to know that gravitational force is the weakest force. After that, weak nuclear force. After that, electromagnetic force. After that, strong nuclear force. Now here, from gravitation to up to strong nuclear force, we consider strength is in increasing order. Here a bigger or strongest force is strong nuclear force. After that, electromagnetic, weak nuclear, and gravitational, decreasing in order, increasing in order from gravitational, weak nuclear, electromagnetic, and strong nuclear. Here gravitation is the weakest force in the nature. Strong nuclear force is the strongest force in the nature. Again, continuation of this topic, last important scope. I already said objective. There are 5 objectives we already learned. Out of 5 objectives, we already learned 4 objectives. And the last objective is nature of physical law. And here, especially in the nature of physical law, it mainly gives idea and how we can apply the law, especially conservation laws or laws of conservation. And again, that laws of conservation, how we can apply depending on a system. We can't apply the conservation law in all the cases. Here, system to system or concept to concept, we can change the application part of conservation law. That we are going to learn under nature of physical law. Dear student, we discussed the last 5th important objective part, nature of physical law. That nature of physical law mainly explaining about 2 important things that I said. First one is conservation law, second one is size. Depending on these 2 important things, we can see the nature of physical law. Remember student, we already learned there are fundamental forces in nature. Along with the fundamental forces, there are different kind of other forces. And all that forces are classified depending on conservative and non-conservative nature. Depending on conservative and non-conservative nature. Keep this point clearly in your mind. We're going to discuss these 2 things in the coming chapters. Up to that, we're going to do. I give a clear idea related to what is a conservative and non-conservative force. Conservative force is the one is depending on initial and final point, is not depending on a path. Example, force of attraction between sun and earth. Force of attraction between earth and moon. Here the path is not required. It is independent of the path. Force is independent of the path. But it depending on initial point and final point. If I consider earth and moon, earth is the initial point, moon is the final point. Path is not required. Here gravitation force, what we learn in between earth and moon, is depending on initial and final point, not depending on a path. Such a type of forces we call it as conservative forces, and a non-conservative force is the one force between any 2 objects depending on a path. Best example, if I write by using pen over a board, whatever things I want to write over a board, just imagine conservative, what I wrote, what the writing is there on the board is mainly because of friction between pen and board. In between board and pen, there will be a frictional force. In between a tire of a car and a road, there will be a frictional force. Without friction, car can't move. Without friction, we can't write over a board. And whatever force we consider now frictional force comes under category called non-conservative. Non-conservative is the one both the forces or both the object both are in contact. That indicates that path is required. Now any force which depending on a path is independent of initial and final point, that kind of force we call conservative. And by considering that, we can think about conservation law and size also. Dear student, remember that in a conservation law, we can think about 4 basic conservation law in nature. First one we call it as a laws of conservation of mass. You learn in lower class, mass is conserved. Second one is called a laws of conservation of energy. You learn energy neither be created nor be destroyed. Third one is called conservation of momentum. It may be a linear momentum or angular momentum. And the last one is called conservation of, we can think about conservation of momentum I said, conservation of energy I said, conservation of mass I said. Last one is called conservation of charge. Dear student, in a physics we can think about 4 important: conservation law, conservation of energy, conservation of mass, conservation of momentum, conservation of charge. By considering that, we can think about conservation law. That conservation law is depending on a different cases. Just imagine if I consider this pen is at a particular height. This pen got only the one kind of energy. That energy we call it as potential energy. Because the pen in the state of rest, there is no velocity. We can't say kinetic energy. Automatically this pen got only one kind of energy. We call it as potential energy. As pen falling down, just imagine here is the pen. The pen is at a particular height. Is in the state of rest. Pen got a energy. That energy we call it as potential energy. As a pen start falling down, potential energy goes on, decreases, automatically kinetic energy goes on, increases. At this particular point, pen is in the state of motion with a particular velocity v. At this particular point, pen got both potential energy as well as kinetic energy. But here potential energy may be less, kinetic energy may be more. Pen is moving from this particular point to here. Most of the potential energy is converted as kinetic energy. Now by using this example, we learn laws of conservation of energy. Energy neither be created nor be destroyed. Energy is conserved. We can transfer one form of energy to another form of energy. Especially this potential energy and kinetic energy you learn in lower class. Both are the 2 types of energies comes under category called mechanical energy. That's why potential energy and kinetic energy are called mechanical energy. And again here we can't use the word called friction. If I count the friction, automatically there will be a change in the system. That's why to study the physical law we have to neglect the few things. To study the laws of conservation of energy, if I neglect the friction, then only I can think about laws of conservation of energy. If I count the friction, if a pen is falling down, you already know air is start moving above, or air going to apply a force on a pen in upward direction. There will be air resistance. That air resistance itself we call it as friction. By neglecting the friction, we learn laws of conservation of energy. That's why to learn the nature of physical law, we have to consider certain limitation. There will be a certain concept you have to neglect. That's why depending on that we can think about conservation law. Next important thing, size also. Again depending on a size also, one of the parameter. By using that parameter we can study the different cases. It may be a thermodynamics, it may be a mechanics, or it may be a nuclear physics, it may be atomic physics, like that. Again depending on that we can think about different systems. We can think about Einstein's theory, Einstein's relativity theory. All those things comes under nature of physical law, and especially these two we can explain in a broader way in a different concepts. But here I consider few examples, and whatever concepts we learn in a physical world topic, I said in a first previous 2 video itself, the physical world topic is a general topic in a physics. we can explain in a broader way also, but exam point they're going to ask the minimum questions, only a 1 marks 1 question, or 1 marks 1 question for 2 marks. That's why here this is the broader concept. You can explain in more deeper way also. Whatever concepts we learn in a physical world topic, it is explains entire things what is there in physics in first year and second year. Up to here we're going to wind up or end the physical world chapter, and after completion of this video we provide certain important questions or assignment also. You have to work out that assignment, you have to submit the assignment also. Thank you.